Welcome. Here we are in Unit 8, and today we look at Day 2, Equations and Inequalities Involving Absolute Value. In fact, we'll focus on the equations part of that. We are in Section 1.6 of the book, and we will look at Objective 1, Solve Equations Involving Absolute Value. So I'll start with the basic idea, and then as you can see on the left, we just have a bunch of examples. Here's the basic idea. The absolute value of a positive number is just that number again. The absolute value of 5 is 5. But the absolute value of a negative number, to get that, I multiply that negative number times a negative 1. It's the positive version of the negative number. So the absolute value of negative 5 is positive 5. So based on these two expressions here, if the absolute value of x is 5, then what do you know that x could be? Either x equals 5, that was in the first case, or x equals negative 5, that was like in the second case. We're going to see this rule again and again and again throughout the exercises today. Every example kind of has this form. If the absolute value of something equals something else, I don't know, just stuff. If the absolute value of something equals stuff, then there are two possibilities. Either that something equals the stuff, or the something equals negative the stuff. All right, so that's the idea we will see again and again today. Here are the 8 examples that we're going to look at. So they're roughly ordered in increasing interest, increasing challenge. In this video, I'm not going to use the pause and try like I've done in the past. I just encourage you to do that for each of these examples. When I throw it up on the screen, pause the video for a second, try to work it out on your own, and then when you're ready, see how I do the problem. All right, let's go through these examples. Example 1, solve the absolute value of 5x equals 30. The stuff inside the absolute value, that's either 30, or it could be negative 30. So really I have two equations, 5x equals 30, or 5x equals negative 30. So by changing it into two equations, I drop the absolute value, and now I can solve each of these equations separately. 5x equals 30, so divide both sides by 5, and I get x equals 6. Or, again, divide both sides by 5, x equals negative 6. Those are the two solutions to this problem. Example 2. Solve the absolute value of 2x minus 7 equals 21. So right away, if I drop the absolute values, I get 2x minus 7 equals 21, or 2x minus 7 equals negative 21. So I just have two equations to solve. In the first case, I'll add 7 to both sides, 2x equals 28, and then divide by 2, x equals 14. In the second case, I will add 7 to both sides, so 2x equals negative 14, and then divide by 2, x equals negative 7. So those are my two solutions, x equals 14 or x equals negative 7. Example 3. Solve 3 times the absolute value of x minus 5 plus 7 equals 19. There's a little bit of work we need to do before dropping the absolute value. In all of my previous examples, the absolute value has stood on its own on one side of the equation. I need to get it that way. I need to isolate the absolute value. So first, let's solve this equation so that the absolute value is by itself. We'll subtract 7 from both sides. 3 times the absolute value of x minus 5 equals 12. Then I'll divide both sides by 3. And I get the absolute value of x minus 5 equals 4. And now I can drop the absolute value and turn it into two equations. So either x minus 5 equals 4, or x minus 5 equals negative 4. In the first case, I'll add 5 to both sides, x equals 9. In the second case, add 5 to both sides, x equals 1. And there we go. Those are the two solutions to this problem, x equals 9 or x equals 1. Example 4. A similar problem. Let's solve this equation. So I need to get the absolute value by itself. So let's subtract 7 from both sides. 3 times absolute value x minus 5 equals negative 6. Divide both sides by 3. Absolute value x minus 5 equals negative 2. And at this point, stop. You are done, right? Because does this equation have any solutions at all? Don't try to take down the absolute value and turn it into two different equations. If you did that, you could get answers, but they would be extraneous solutions because I can't take the absolute value of anything and end up with a negative number. So no solutions. Example 5. Solve the absolute value of x plus 1 divided by 2x plus 3 equals 5. This looks more complicated than the other ones, but it's really not. I just drop the absolute values and turn it into two different equations. So either x plus 1 over 2x plus 3 equals 5, or x plus 1 over 2x plus 3 equals negative 5. So let's just go through and solve these two equations. The first step will be to multiply both sides by 2x plus 3. So x plus 1 equals 5 times 2x plus 3. Then distribute the 5. Now I need to solve for x, so maybe I'll subtract x from both sides. And then subtract 15 from both sides. And now I can solve for x. There we go. On the right, I'll follow the same process. So multiply both sides by 2x plus 3. X plus 1. Distribute the negative 5. Now let's get all the x's together. Maybe I'll move my x's to the left this time. So I'll add 10x to both sides. 11x plus 1 is negative 15. Subtract 1 from both sides. And now I'm about ready to solve for x. There we go. Example 6. Let's solve this equation. Once again, it maybe looks a little more complicated than it really is. There's an absolute value on the left and a number on the right, so we'll just drop the absolute value signs and turn this into two equations. X over 2 minus 2/3 equals 1, or x over 2 minus 2/3 equals negative 1. Now in each case, my goal is to solve for x, so maybe I'll add that number out of there and then multiply by 2 to get x by itself. So x over 2 equals 1 plus 2/3. Can I simplify that right-hand side? Let's get a common denominator. So 1 is the same as 3/3. So 3/3 plus 2/3 is 5/3. Then if I multiply both sides by 2, it looks like I get x equals 10/3. How about the equation on the right? I'll do something similar. So let's see, x over 2, I'll add 2/3 to both sides. Negative 1 plus 2/3. The common denominator is 3, so I have minus 3/3 plus 2/3. Let's see, minus 3 plus 2, that's negative 1/3. And then multiply both sides by 2, x equals negative 2/3. There we go. Those are our two solutions. Example 7. This one introduces two new things. I have an expression on the right, not just a number, and I also have an x squared, so maybe something quadratic will come out of this. Well, like before, the absolute value is by itself on the left, so I really can drop the absolute value and then take plus or minus the right-hand side. So that becomes x plus 1 equals x squared minus 1, or x plus 1 equals, now here is where I need to be really careful. It's the negation of x squared minus 1. So that negative sign is going to distribute, and that gives me negative x squared plus 1. So now we just solve each of these on their own. Okay, so let's see here. On the left, let's push everything over to the left. So I'll subtract x squared, so minus x squared, and I'll add a 1 also. So I end up with x squared plus x plus 2 equals 0. Pause the video and check that if you need to. This is almost in standard form. Standard form says that I should have a positive coefficient in front of my x squared. So let's multiply both sides by negative 1 times a negative 1 times a negative 1, and I get x squared minus x minus 2 equals 0. There we go. Now it's in standard form, and I can factor. Can I factor? Actually, maybe I should check. I think so. How about x minus 2x plus 1 equals 0? I think that'll work. So the solutions to this are x equals 2 or x equals negative 1. How about the right-hand side? Let's move everything over to the left so that negative x squared comes over to the left and becomes a positive x squared plus x. And it looks like if I subtract 1 from both sides, oh, all my constants fall away. And so I just have 0 there. Let's factor an x out of that. X times x plus 1 equals 0. And so we find x equals 0 or x equals negative 1. So the negative 1 was repeated. So it looks like I have a solution set of negative 1, 0, and positive 2 as the solution set. I'll try it again. But wait, I have made a mistake. Do you know what my mistake is? There's something not right in this problem. Those are not the solutions. It turns out one of those is an extraneous solution. Do you see? 0. What would happen if I put 0 back into my original equation? If I put 0 in for x, then I just have 1 on the left. And if I put a 0 in for x on the right, I get negative 1. Well, those are clearly not equal. So it does happen occasionally with absolute values that we need to double check our solutions and watch out for extraneous solutions, things that just don't work. All right, so here we go. Erase that, and there we go. So this is the solution set to the problem. And you should check right now. See what happens if you plug in negative 1. Does that work? What happens if you plug in positive 2? That works also. Okay, last example. Solve this. What's different here? Well, of course, we see that there are absolute values on both sides. Well, it turns out that if you have expressions like the absolute value of A equals the absolute value of B, then we can drop absolute values from both sides, and we still end up with two equations, A equals B or A equals negative B. Perhaps you can convince yourself that this is true by maybe imagining that both of these are equal to some actual number, 5. What if they were both equal to 5? What could A be? What could B be? Well, A can only be plus or minus 5. B can only be plus or minus 5. So in fact, either A equals B or A equals negative B. So even without the 5 there, those two things equal some number, the same number. So they either equal each other or they equal negatives of each other. All right, so then we can solve this. This turns into two equations. 2x plus 3 equals 5x minus 1. Or, now here's where I need to be really careful with my negative sign. 2x plus 3 equals, watch it here, negative 5x plus 1. I've negated that 5x minus 1. And let's solve. So in the first case, maybe I'll subtract 2x from both sides. 3 equals 3x minus 1, minus 1. I'll add 1 to both sides. 4 equals 3x. Divide both sides by 3. 4/3 equals x. And we've solved that equation. On the right, I will add 5x to both sides. 7x plus 3 equals 1. And then let's subtract 3 from both sides. 7x equals negative 2. And then divide both sides by 7. X equals negative 2/7. And there we have it. We've got our solution. So in this problem, there are 2 possible solutions for x equals 4/3 or x equals negative 2/7. For all of these problems, hopefully you've seen some similar strategies. We basically try to isolate the absolute value and then turn it into 2 equations without absolute values that can be solved using other techniques. All right, review if you need to, make sure that you can do these things, and I will stop here.